everybody. My name is Miss Cassie. I work at the City of Austin Watershed Protection Department. And today I'm going to share with you our watershed model, and we're going to have a scientific investigation. So let's get started. All right, first here we have what we call our watershed model. And you'll see these little houses on the tops of all the hills, and there are 5 of them. And then in the middle here, we have this blue section, which is labeled Middle Creek. So that is a water body, that's a creek. And then it's flowing down here, and this is a little bit harder to see, but this is labeled the Colorado River right here. Now the Colorado River is a very important river here in Austin, because that's where we get all of our drinking water from. All right, now we are going to take off the top layer of our watershed model, and we're going to reveal what's underneath. This is the aquifer layer. So this is supposed to represent a limestone, a karst limestone aquifer like we have here in Austin. We have the Edwards Aquifer, and it's a really big rock layer that holds fresh water underground. All right, guys, you might notice that now we have holes that are kind of in the middle of our watershed model. Now these holes represent places on the landscape that water on the surface can enter and seep down and get into our aquifer layer. And we call this area a recharge zone. And the way to think about it is at night, almost everybody uses this to plug in their phone, and we're charging our phones so that they have fresh energy so that we can use them the next day. So similarly, that is the aquifer being charged or recharged with fresh water, and that's rainwater and surface water seeping down through these holes and getting down into that rock layer. So that rock layer, most of it here in Austin is made up of a rock like this. You've probably seen it everywhere in parking lots and playgrounds. It's a type of limestone. It's called karst limestone. And you may notice it has a bunch of holes in it. So this sits on the surface, mostly around West Austin area. And that's where our recharge zone is. And so from the surface, rainwater can seep down through all these holes and down into our aquifer. So that's why we call it the recharge zone. All right, guys, we are almost ready to start our investigation. So go ahead and take a look at our watershed model here. Watershed is just an area of land that drains water. So if you are standing on land, you are on a watershed. So what we're going to do is I have a problem. I have a scenario, and I hope you can help me solve it. So I'm going to tell you, we're going to start right now. So I have a friend named Sally, and she lives in one of these 5 houses. She decides she wants to change the oil in her car. So she goes outside, she does it, but she accidentally spills a little bit of oil. And she's like, uh-oh, how do I clean this up? So she comes in and calls me, and I say, oh, that's no problem. You just have to get some clean cat litter or something absorbent like sawdust, put it on top of the oil, and it will soak up the oil. And then you can put it in a trash can. And she says, great. She goes back inside, she has homework, she has to make dinner, she gets tired and goes to bed. But what did she forget to do? Yep. She forgot to clean up the oil. And guess what happened that night? It rained. So your job is to tell me which house Sally lived in if when it rained, she ended up polluting both Middle Creek and the Colorado River. So I want you all to think just a few seconds to come up with your own hypothesis or your own educated guess. Where do you think Sally would live? All right, I have a volunteer with me now, and this volunteer has, we've told them the scenario. And what do you think? Which house does Sally live in, do you think? What's your hypothesis?
I think Sally lives in this house because it's the only house that's uphill from Middle Creek.
All right, well that's great. Let's go ahead and test your hypothesis. Go ahead and put a couple of drops of the green dye next to Sally's house. And that's going to represent our oil pollution. Uh-oh, whoops. Wow, that's already starting to get down in Middle Creek. Now we are going to simulate the rainstorm. So our volunteer is going to take this rain cloud and rain on top of where we think Sally lives. All right. Very good. So I see a little bit of this dirty water, or that oily water, stuck behind here at Middle Creek. So do we think our hypothesis was correct?
Sure, I see water both in Middle Creek and in the Colorado River.
Yeah, I think that's great. And it seems like that's the only house that could have polluted both. If you had picked any of these other houses, they are in different watersheds, and the water would have been going away from Middle Creek. So now we need to figure out if Sally polluted our aquifer. So we're just going to carefully take off the top layer here and look at our aquifer layer. Oh! All right, so here we do have some of that green water representing our polluted water, as well as all of this pollution over here. So even if she didn't mean to, she did end up also polluting our aquifer because she lives in the recharge zone. Thank you for joining me today. I enjoyed sharing our watershed model with you. You can see how really important it is that each and every one of us do our part to help reduce pollution in our watershed. Anything that you use in your house, your cleaning products, things you might put on your yard or in your garden, and any leaky oil that's coming out of a car, all of these things can contribute to water pollution. So at the bottom of the screen is our web address. We'd love for you to visit us there. There's a lot of fun activities to do. There are maps, watershed maps, some more watershed game activities, fun things to do at home. So go ahead and check all that out. There's more videos as well. We even have masks that are fun to color. And this one is of the Barton Springs salamander, who is an endangered species here. Alrighty. So that's all we got for you today. This is the Barton Springs salamander saying adios.